Okay, in this video we're going to be talking about proofs. Now a little bit later in the course we're going to be doing some geometric proofs, proofs involving geometric figures. But in this video we're going to be doing something called algebra proofs, which just means solving algebraic equations in a particular kind of formal method to learn about how proofs are done using what's called a two-column format. So take a look at example number 1. We have this conditional statement: if 2x plus 3 equals 15, then x equals 6. So this is a conditional statement. It's an if-then form, and I can label my hypothesis and my conclusion here. And this conditional statement it's a little bit different than the conditional statements we've been looking at before, because this just looks kind of like the beginning of what we would call an algebraic equation, and this just looks like the solution to the equation, and that's essentially what it is. When writing an algebra proof, the hypothesis is what is given. And we're going to talk about this in just a minute. The hypothesis is what is given. So 2x plus 3 equals 15, this is the given part of our proof. And the conclusion is what you are to prove. All right, so the format of a typical proof, you have a given piece and you have a prove piece, and they match up to the hypothesis and the conclusion of a conditional statement. Now, something that I want to note here about algebraic proofs: for this particular equation right here, 2x plus 3 equals 15. Now, if we were just going to solve this equation in the normal way, it wouldn't be that difficult. It would look something like this. We'd subtract 3 from both sides, and that would give me 2x equals 15 minus 3 is 12. And then I would divide both sides by 2, and that would give me x equals 6. And then I'd be done. And that's essentially what we're going to be doing when we do algebra proofs, except instead of, kind of marking through here and drawing the line and then drawing the lines, each individual step that we do in the proof is going to have its own line. So we're going to be writing down individual lines. And as we do each step in the proof, as we do each step solving the equation, we're going to state and write down a reason for each one of our steps. So let's take a look at how that's going to look. So here's our equation that we started with. And notice it says given, 2x plus 3 equals 15, prove x equals 6. All right, so here's what a two-column proof would look like for this particular problem. A two-column proof, there's this little, what's called a T-chart that we draw right here. And one column we label statements, and the other column we label reasons. And we start out with step number 1. And step number 1 is always the given part of your proof. Sometimes you have more than one given statement. In this case, we just have one. So we're going to start with that. 2x plus 3 equals 15, and the reason that we start with that, the reason that we have that statement, is because it's given. All right. So step number 2. Step number 2, remember from solving it before, we're going to subtract 3 from both sides of the equation. Well, instead of doing it like I did before, which was, write down the negative 3 here and then draw a line and then I'm going to write a whole separate line here in which I subtract 3 from each side of the equation. So 2x plus 3 minus 3 equals 15 minus 3. So what I've just done is subtracted 3 from both sides, and I've written it on a single line in my proof. Now, the reason that I can subtract 3 from each side of my equation is there's something that we talked about just recently called the subtraction property of equality. The subtraction property of equality says if I have two things that are equal to each other, like 2x plus 3 and 15, then I can subtract the same thing from each one of those quantities, and that's what I've done right here. So this, subtract 3 from this side, subtract 3 from this side, that's just the subtraction property of equality. Each one of our reasons here is going to be one of our properties of equality. So my next statement here. I'm going to do what normally I would call collecting like terms. My positive 3 and my negative 3 kind of cancel each other out, and my 15 minus 3, I combine those into 12. But collecting like terms is not one of the reasons that I use. And the reason that I'm going to be using here is actually going to be the substitution property of equality. And what I'm substituting is positive 3 and negative 3. I'm going to substitute 0 for that value right there. So 2x plus 0, if you want to think of it that way. 15 minus 3, I'm going to substitute for 15 minus 3, I'm going to substitute the quantity 12. And I have 2x equals 12. And the reason I can write that is because I've substituted 0 for this quantity and 12 for that quantity. Now my fourth step, I want to divide both sides of my equation by 2. And rather than just do it right here on this line here, I'm going to give it its own line. So 2x divided by 2 equals 12 divided by 2. The reason, this is my division property of equality. And now finally my last step, my 2's are going to cancel out here, which gives me x. 12 divided by 2 is 6. And this one, it may be difficult for you to see, at least for right now, but again what I'm doing here is I am using my substitution property of equality, and for 2 divided by 2 I'm going to substitute 1. So this 2 divided by 2 becomes 1, if you want to put the 1 there. And this 12 divided by 2, I'm going to substitute 12 divided by 2, I'm going to substitute 6 for 12 divided by 2. So that's going to be my substitution property of equality. And we've just done our first algebra proof. Let's take a look at example number 2. Given 2 times 5x minus 3 equals 8 plus 3x, prove x equals 2. All right, so I'm going to start with my given statement. Step number 1, 2 times 5x minus 3, 8 plus 3x. Reason, that's my given statement. So the first thing I want to do here is I want to multiply through my parentheses here. So 2 times 5x is 10x. 2 times negative 3 is negative 6. And hopefully you recognize that as just using the distributive property of equality. So that's my reason here. Distributive property of equality. My next thing I want to do here, let's see, how about if I add 6 to both sides? 10x minus 6 plus 6. Remember, I'm going to put everything on its own individual line. So I'm going to add 6 to this side, which means I'm going to add 6 to this side. That's the addition property of equality. Step number 4, I want to collect like terms again. 10x minus 6 and plus 6, I'm going to substitute 0 for that, so that just leaves me with 10x over here. And collecting like terms here, 8 and 6 gives me 14, so I'm going to subtract the quantity 14 for 8. I'm going to substitute the quantity 14 for 8 plus 6, so I'm using my substitution property. And let's see, my next step here, I want to get all my x's together, so I'm going to subtract 3x from each side of my equation. So subtract 3x from this side, 3x plus 4, subtract 3x from this side. And my reason for doing that is that's the subtraction property. And once again, I'm going to collect my like terms, which means I'm going to be substituting. So in this case, 10x minus 3x is 7x, so I'm going to substitute the value 7x for 10x minus 3x. And here I've got 3x, positive 3x and negative 3x, which means all my x's go away. So I'm going to substitute 0 for these two values here, which means I just have 4 left over. And that's substitution property. And let's see, my next, and it looks like I have an error somewhere. I'm trying to prove that x equals 2, and it doesn't look like that's what I have. Oh, 14. 14, so this is 14. Okay. Now, I would like to get x by itself, which means that I need to divide both sides of my equation by 7. So, 7x divided by 7 equals 14 divided by 7. That's the division property of equality. The division property says if I have two quantities that are equal to each other, I can divide each of them by the same number. And once again, I'm going to substitute the value 1 for 7 divided by 7. And I'm going to substitute the value 2 for 14 divided by 7. So my reason here is, once again, the substitution property. And I've just finished that proof. This one took 8 steps to do that algebra proof. All right, example number 3. Have a given statement here, 7x plus 16 equals 3x plus 48. So let me start with that. 7x plus 16, 3x plus 48. That's my given statement. And let's see, my first step is going to be, let's see, I'd like to get all my constant terms together and all my x's together. Let me start by subtracting 16 from both sides. So 7x plus 16 minus 16, 3x plus 48 minus 16. And since I'm subtracting the same thing from both sides of my equation, I'm using the subtraction property of equality. And now I'm going to collect like terms. My 16s are going to go away. I'm going to replace 16, positive 16 and negative 16 with 0. I'm going to substitute 0 for that. And for this side, 48 minus 16, I'm going to substitute the value 32. So I'm using my substitution property of equality. Step number 4, I want to get all my x's together, so if I subtract 3x from each side of my equation, then I'm going to get all my x's together. So 7x minus 3x equals 3x plus 32 minus 3x. And let's see, subtracting the same thing from both sides of the equation means using the subtraction property of equality. And here, once again, I'm going to be collecting like terms, which means I'm going to be using my substitution property. And let's see, right here, I'm going to substitute the value 4x for 7x minus 3x. And over here, positive 3x and negative 3x means those 3x's are going to go away, so I'll have 0 x's. So I'm going to substitute 0 for that, and that leaves me with just 32 on this side. And let's see, I want to get x by itself, so I'm going to want to divide both sides by 4. 4x divided by 4, 32 divided by 4, and since I'm dividing both sides by 4, I'm using my division property of equality. And finally, one more time, I'm going to use my substitution property. Here I'm going to substitute the value 1 for 4 divided by 4, so that's going to be 1x, or just x. And I'm going to substitute the value 8 for 32 divided by 4. So that's, once again, the substitution property. Substitution So you start to notice some things about how these proofs look. They always start with the given statement. They always end with the prove statement. That is the prove statement, what it is you're trying to prove. That's always the last statement in your proof. And each one of the additional statements are just whatever the next thing is that you need to do in order to solve your equation, accompanied by the corresponding reason. All right, let's take a look at this last one. I'm going to get you started on this one, and then I want you to finish it on your own. I've got a given statement here, my equation, and then here's what I'm trying to prove. So once again, I want to start with my T-chart. Statements and reasons. And my first statement is going to be my given. So that's 2x minus 13 over 3 equals negative 9. And that's my given. Now, the first thing I want to do here for my step number 2 is I want to multiply both sides of my equation by 3. The reason I want to do that is if I multiply both sides of my equation by 3, then that's going to allow me to cancel out my 3 in the denominator here. I'm essentially going to be getting rid of my fraction. So if I multiply both sides of this equation by 3, then it will look like this. Now, what's the reason that I can use when I multiply both sides of the equation by the same number? Well, that reason is going to be the multiplication property of equality. And if you look at your chart with your properties of equality, the multiplication property is the property that says if you have two quantities that are equal to each other, you can always multiply both of those quantities by the same number, and they will still be equal to each other. So that's what we've done here, multiplying both sides by 3, which means the 3's cancel out here. And I've got 2x minus 13 equals negative 27. And I'm going to let you fill in the reason for that one and then also complete the rest of the proof. And we'll take a look at these in class tomorrow.